we're going to calculate the same problem that we did in our relative frequency example. But in this case, instead of using a probability tree, we're going to use the Bernoulli process to do that calculation. And so I've gone ahead and written out all of the variables in the Bernoulli process. Our same problem is we want to calculate, if we flip a coin 3 times, what is the probability of it landing on heads 2 times? And so to calculate that, like I said, we're going to use the Bernoulli process. The variables for that are listed right over here. I'll go ahead and write out the formula. The probability of x, of this happening, of it landing on head 2 times, is equal to the factorial of the number of trials times the probability of success on a single trial to the number of times the outcome occurs. That's multiplied by the probability of failure on a single trial. It's represented with a Q. To the number of trials minus the number of times the outcome occurs. So there's another X right there. That's the top part of your formula. All of that is put over X factorial, the number of times the outcome occurs, the factorial of that, times n minus x, which is the number of trials, minus the number of times the outcome occurs, factorial. So all we have to do now is plug in our numbers for our situation. And so this is equal, the probability is equal to, in our case, the number of trials is 3. And so the factorial of that is 3 times 2 times 1. We're going to multiply that by the probability of success on a single trial, which is 50%. It's a 2-sided coin, so I'm going to put 0.5. And that's to the power of the number of times the outcome has to occur. And so we want it to land on head 2 times. So I'll put that 2 right there. Multiply that by the probability of failure on a single trial, which again, with a coin in our case, that's 50% that we're not going to get ahead. And then that is to the power of n minus x, the number of trials. And again, in our case, that is 2 minus the number of times the outcome occurs, 1. So we put all of that over x factorial this time. X is the number of times the outcome occurs. We want it to happen 2 times, landed on head 2 times, so 2 times 1. We multiply that times n, again, which is the number of trials. And then you multiply that by the number of times the outcome occurs. So it's 3 for the number of trials minus the number of times the outcomes occurs, which is 2. And then the factorial of that, of 1, is just 1. So that would just be 1 times 1 there. You simplify all of this, and you get the same 0.375 or about 38%. So instead of using the probability tree that we used in the example for relative frequency, we use the Bernoulli process, which will allow us these variables to define and put into an equation, which will give us the result, which is a much more efficient process, especially if you have multiple variables and multiple things happening.